Hi, I'm Aurelio Cortese, principal investigator and senior researcher at ATR. And today with this poster, I will introduce to you some of the research that we do in the lab, specifically about metacognition and the functions of metacognition, how it supports the solving of complex problems, and how confidence may be the key to our unconscious brain activity. How can the brain learn new behaviors so efficiently? If we think of current state-of-the-art artificial intelligence, this usually requires millions of data samples. The brain does not. It can solve problems with astronomically high numbers of dimensions simply by trial and error. The goal of this study that I introduce here was to provide an unbiased test of this objective ability that humans have to learn incredibly complex tasks in terms of dimensionality. Moreover, we aim to uncover what is the underlying mechanism. So in this study, we combine functional magnetic resonance imaging of brain activity with a real-time neurofeedback paradigm based on machine learning. To anticipate, our results show that humans can learn to use non-conscious information in their own brain to select an optimal action. And strikingly, the confidence in one's own cognition may be the secret of this learning ability. How was the experiment performed? We first recorded participants' brain activity with an fMRI while they watched the screen with small dots moving either to the right or to the left. These brain activity patterns were used to train a machine learning algorithm. Next, in the learning experiment, we took the following steps. On each trial, participants' brain activity patterns were fed to the machine learning algorithm, which outputted a label, in this case, L or R, as you can see here. Participants didn't know this and had to bet on one of two options, A or B. If the algorithm output was L, then the optimal action was B. If the algorithm output was R, then the optimal action was A. So the brain had to learn to associate patterns of activity with an action in order to get rewards, which in this case is an extremely difficult task because we know that these patterns of activity are extremely high dimensional and there's an almost infinite number of these non-conscious brain states. So we found that participants could learn the task, but most interestingly, that confidence seems to play a central role. First of all, participants were better at introspecting, were also more likely to have a higher baseline performance in the learning task. That is, those who are better at introspecting their thoughts or their choices are also more likely to be able to use their non-conscious brain information. Second, the trial-by-trial confidence judgment also predicted betting accuracy, so betting on the best of the two options. And finally, most importantly, as learning progressed, the brain regions that controls reinforcement learning and the brain region that controls metacognition became more and more synchronized. So you can see it here in this figure. So with learning, the connection between these two regions became stronger and stronger. In the future, we want to understand how cognitive functions support reinforcement learning of complex high-dimensional problems. And these studies are expected to bring several advances in science and beyond. Understanding the basic mechanism of cooperation between reinforcement learning and metacognition will contribute to future applications in brain science and education, as well as in medical science. Importantly, better understanding the depth of the brain's ability to learn new problems, adapt to new circumstances is very important in these days, especially when we think of the current coronavirus pandemic. With this, I give you an introduction of my and our lab's research. I hope you've enjoyed it, and feel free to reach out and to write an email. You can see the address here at the bottom of the poster if you have questions or if you would like to further discuss this research. Thank you very much for your attention.